This video is equations with natural logarithms, base e. I probably haven't mentioned that so far actually, that the base e there, we often call these natural logarithms. Okay, so base e, natural logarithms. Let's have a look at a really easy equation first up. Log 3 to the base e, log x to the base e. So what we've got here is a situation we've got log base e on both sides. When we get log base e on both sides like that, we can just drop both of those, there and there. Okay, and it just becomes x equals 3. Simple as that. You can only do that when you've got log on one side and log on the other side. Next question. Now, just mentioned here you can drop the log out if you've got a log on the left and a log on the right, base e. You can't drop them out or cross them out or cancel them out when you've got 2 on one side and 1 on the other. So we have to fix this up first. Okay? So what we can do here is use our log rules that state if we've got 2 log expressions with the same base added together, we can keep that same base and multiply those two there. So we get log 3x to the base e equals log 6 to the base e. Now we've got log base e on that side, log base e on that side. 3x equals 6, x equals 2. Another one, it's a bit similar here. So 3 log expressions here on the left and 1 on the right. Let's get them together. They've all got the same base, remember. So we can get log base e. We can multiply the x by the 5. That gives us 5x. And then because we're subtracting here, okay, subtracting there, we put it over the 10. Okay, when we subtract expressions with the same base, we divide. And that equals log 3 to the base e. So now we've got log base e this side, log base e that side. So we can now drop those out and we get 5x over 10 equals 3. 5x equals 30 by timesing through by 10. X equals 6. Next one, let's employ those same rules again. Okay, we've got log base e. We multiply because we add 2 expressions with the same base. We multiply those together, so that's x times x plus 1 equals log 2 to the base e. Now got log base e on both sides, there and there. Okay, we can now cancel those out. And we get x outside of x plus 1 equals 2. Now, some people get stuck here. You've got to recognise this is leading to a quadratic. Expand the brackets. X squared plus x squared plus x equals 2. We've got an x squared term, an x term and a number. By itself, on that right hand side, we bring it over, like so. X plus 2. X minus 1 equals 0. X equals neg 2 or 1. Need to be careful. We need to check the viability of these answers. Because if I look up here and we look at the fact that we've got log x to the base e over there. So we're saying at the moment that one of our solutions are neg 2 and 1. Let's look at this guy here, neg 2. If we put neg 2 back into here, okay, that is undefined. Okay, we cannot get a negative number in that position there, okay, to the base e. So that means neg 2 is not a viable solution. We've only got one solution, and that's x equals 1. So please check if you think you've got 2 possible solutions, substitute one of them back into the original. And if you get a negative situation there, that solution is not a viable one. Okay, next question. E to the power of log, natural log x equals -2. Okay, so I've changed the terminology there from ln x, ln x, to log x to the base c. There's a little rule that I want to introduce you to that says a, it wasn't one of our rules before, so please take note of this, a to the power of log x to the base a equals x. Okay, so that simplifies, or that all simplifies to just x. So here I can just simplify that expression there to just x. So x equals 2, and we're done. So please remember that. Okay, a to the power of log x to the base a is equivalent to x. And that's pretty much it for that section. So you can now do exercise 3F on page 147. Numbers 1 through to 7.